We have a quiz coming up on multiplication of fractions, and just want to go over a little review. Not a lot of questions, but just emphasizing stuff to study tonight. First, if we're looking at a model and we're trying to determine the area of the rectangle, what equations could we fit the model? First thing we're going to look at, you notice there's 4 columns, so we know it's going to be something over 4, and whatever is shaded would be the numerator. And for the rows over here, we know it's 2, so we know the denominator is going to be 2. But we also know that it cannot be more than the denominator. So we cannot have 5/4 because there's only 4. So we could have 4/4, but we could not have anything bigger. So you notice for all possible equations, we have 1/4, 2/4, 3/4, and 4/4, but nothing bigger than the denominator. So we could have 1/4 and 1/2, 2/4 and 1/2, 3/4 and 1/2, and then we start over with 2/2, our 1 whole, 1/4, 2/4, 3/4, and 4/4. Next thing we want to emphasize is the meaning of the multiplication problem. The word of means to multiply. So anytime there's a of in there, we multiply. So on the first one, finding the area of, the of is the multiplication, the length and the width. So area, so we're just going to 2/3 times 3/5. So we just multiply straight across. 2 times 3 is 6. 3 times 5 is 15. And then we look to see if there's a number that can go into both of those. And we know that 3 goes in, so we're going to divide that by 3. Divide that by 3. So 6 divided by 3 equals 2. 15 divided by 3 equals 5. So the correct answer would be 2/5 square feet. Next, we're looking at the area of a floor with the length of 3 yards, and a width of 3 3/5. So this one, we're going to change the number. The whole number is the same. The whole number is the same as the whole number as the numerator, and 1 is the denominator. So what we can do is we can put, since sometimes they'll try to go straight across, but the 3 kind of throws them off. So we're going to put the 3 over a 1. Because that's the same thing as 3. And then we're going to change this to an improper fraction. So that would mean, in order to do that, what we do is we take the 5 times the 3, and then we add the top. Because 3 whole objects, if it's cut into 5, would be 15, the same thing as 5 times 3. So 15, and then we have 3 things left over, so it's 18/5. Okay, so the 3 would be 15/5, and then we have 3/5 to add to it. That would be 18/5. So then we can multiply. When we do that, we got 54 over 50. And anytime the numerator is bigger than the denominator, that means we can make a whole out of that. So I'm going to make this 50 out of top, and 50 on bottom would be 1 whole. And then, whoops, I'm supposed to have 5 on the bottom. So I can make 10 groups. 5 times 1 is 5. So I can make 10 groups of 5. So that would be 50 over 50. Or 50 over 5. The 10 full groups. And then I have 4 left over because 5 times 10 is 50. And then I have 4 left over. Okay. So that's how it would work. So I would take the 3 times the 18 and get 54. 1 times the 5 is 5. And then I'm going to see how many times 5 goes into 54. So I took those 10 whole groups and made them wholes. I have 4 left over, and those are still sections of fifths. So 10 and 4/5. So the steps, put it over 1 if it's a whole number. When you're multiplying, change improper or mixed numbers into improper, and then just multiply straight across. Sarah's car travels 30 miles on 1 5/8 gallons of gas. She wants to travel 60 miles. So therefore, how many gallons of gas will her car use? Since we're doubling the miles, we need to double the gallons. So first, again, I'm going to change that around 1 5/8. 8 times 1 would be 8. So I have 8 plus the 5 is 13/8. I'm going to multiply that by 2. I can always put that over 1. So I have 26 over 8. And then 8 goes into 26 3 full times. And then I have 2 left over because 8 times 3 is 24. So I have still 2/8 left over. So 3 and 2/8. Then what I really could do is reduce this because 2 goes into both of these. So I could have 3 and 1/4 gallons left. Okay. So I just divide if they're both, if there's a number that can go into both of those, just reducing it to make it a smaller number. Next, we're looking at area model. So what area model could be represented by the area model? So since we have 3 columns, I know it can be thirds, and then 1, 2, 3, 4, 5 rows. So I know my rows is going to be fifths. Once again, the numerator cannot be higher than the denominator. So I know it has to be less than 3 on both sides, and less than 5, or less than 5 on this side, and less than 3 up there. So 3 over 1, that would not work. 1/3 and 2/5. So they shaded down 1/3. So 1 of the 3, and they shaded over 2 of the 5. So that one would work. 3, nope. 1/3 and 5/2, nope. So this one, 1 of the 3 is shaded. So 1 of the 3 are 3 divided by 1. Nope, that doesn't work. 1 divided by 3. Okay, so 1 of the 3 is shaded, and 2 divided by 5, 2 is shaded. So 2 of the 5, okay? On a number line, so multiplication on number line is a little tricky. Sometimes you can find ones that work better than others. So this one, 3/5 of, we're gonna change this to of 5, 6. So if we put 5, 6 on the number line, 1, 2, 3, 4, 5, 6, 6, 6 would be the whole. And then we need 3/5 of the way there. So if we have 1, 2, 3, 4, 5, so we need 3/5 of the way there. So we're going to go 3 of those 5. 1, 2, 3. So our new answer would be 3/6, because this is actually a 6th. Okay, so it's 3/6 or 1/2. Okay, if we did it straight across without the number line, 3 times 5 is 15, 5 times 6 is 30, and then we're going to just divide those by 5. Actually divided by 15, and you get 1/2. Okay. Next, what statement correctly describes how the product compares to one of its factors? So on this, we want to understand the importance that if we take a fraction, on this one, it just happens to be 3/5 and 5/6, but we're really looking at 3/5, or most of them. If I take 3/5 and I multiply it by 1, it's going to stay the same. If I take 3/5 and I'm going to multiply it by a fraction, if that fraction is just a little less than 1, my answer is going to be less than 3/5. If I take 3/5 times it by something that is greater than 1, my answer is going to be greater than 3/5. Okay? 1 is going to be equal. less than 1, it's going to be less than my original number. And if it's greater than 3/5, the answer is going to be greater than my original fraction. So what statement corrects? Let's look at these now. 3/5 times 5/6 is less than 5/6. So this is the original 5/6 because we're comparing it to 5/6. So 3/5 is less than 1. So my answer is going to be less than 1. So that works. Is 3/5 times 5/6 is greater than 3/5. So 3/5 times it by something less than 1 is not going to be greater. 3/5 times 5/6 is greater than 5/6. So 5/6 times it by something smaller than 1, it's not going to be greater. 3/5 times it by 5/6 is equal to 5/6. It has to be 1 right here. So that's not going to work. So A is the only possible answer. So this is just helping you do the same thing down here. Choose less than, greater than, equal to the fractions. So if we know the fraction is less than 1 by a fraction, the product is less than the fraction what you're multiplying by. So the same rules, it's just explain it in words down there. So you guys can read over that. So there's just more practice problems for these. So 3/4 times it by 1. So we know it's going to be equal because it's 1 times 3/4. 3/4 times it by something less than 1. So we know it's going to be less than. Then we take 5/4, that's greater than 1, times it by 3/4. So it has to be greater than 1 because the numerator is greater than the denominator. So that's the same thing as 1 and 1/4. So that is bigger than 1. So the answer is greater than 1. This one is 1 times 3/4. So it's going to be equal 2/3. That's not quite 1. So it's going to be less than 3/4. So there's some more examples from that. So just a quick little review. So study up on those and good luck.